Hello, Farouk.
Hello. That's very... Hello, Farouk.
Hello.
How are you today?
Good. Oh, good. All right.
Merry Christmas, everyone.
Merry Christmas.
Merry Christmas.
Feliz Navidad. I didn't say Merry Christmas in Uzbek. Or do you have Christmas in Uzbek? I don't know.
Yeah, we don't have it.
You don't say it. How do you say
I
it in
don't.
Korean? Merry Christmas.
Oh, Merry Christmas. Almost sounds Japanese. Merry Christmas.
But yeah, in movies, when they translate movies that has Christmas, they say Rajestvo. It's Rajestvo in Russian. Christmas is.
Oh,
Okay.
thank you.
Well, Merry Rajastro. All right. Today's a bit unusual since we're meeting a little bit early. Day 24 has not been released yet. We still have an hour to go.
53
So,
minutes.
Let's at least cover 23 or 23. Yeah, we'll cover. Is it 10 we're on now? As answers,
Yes, day 10.
and then maybe by then we can maybe cycle back to 24. And so the video is going to be a little bit out of order today.
Yeah.
But anyhow, let's get started. So day 24, I'll share my screen.
Yeah, day 23.
Up on three. Doo-doo, 23. Oh. This one. A group of amphipods. All right. So
They look like shrimp.
Since we clicked on all the others, we'll click on these as well. Little shrimp, huh?
Yeah.
Are they not shrimp?
I don't know. Is it shrimp and amphipod? Let me see.
No, I think they're smaller than shrimp.
Oh, yeah.
Well, it says that they range in size.
To
Quite,
13 inches, man.
yeah, it's more than a foot. Oh, yeah, they range from tiny, like microscopic, to really big.
Mm.
Hmm. I'm guessing maybe like sea or sand fleas are probably these. But that's kind of a picture. Answer, is that what Google answer are shrimp
I don't know. This says shrimp-like.
and amphipoda.
Shrimp-like in form. Oh.
Yeah. Sometimes referred to as lawn shrimp, with a similarity
Never
to
heard of that.
true shrimp.
Anyways, they're shrimp-like creatures.
Shrimp-like creatures.
Brothers.
Yeah, cousins. Shrimp's cousins.
Cause, all right, so anyway, a group of them noticed my fancy submarine and the flag me down. Oh, actually, who wants to read this one? I'm sorry, I just started reading, but it doesn't have to be me.
I can read it.
All right, good.
A group of amphipods, so shrimp-like creatures, notice your fancy submarine and flag you down. With such an impressive shell, one amphipod says, surely you can help us with a question that has stumped our best scientists.
Oh,
Wow, little amphipod scientists. That's pretty cool. Way down under the ocean. They go on to explain that a group of timid, stubborn amphipods live in a nearby burrow. 4 types of amphipods live there: amber, A, bronze, B, copper, C, and desert, D. A very convenient name.
Mm.
A, B, C, D. They live in a burrow that consists of a hallway and 4 side rooms. The side rooms are initially full of amphipods, and the hallway is initially empty. They give you a diagram of the situation, your puzzle input, including locations of each amphipod, A, B, C, or D. each of which is occupying an otherwise open space. Walls, the hashtags, and open space represented by periods. For example, and we have a little diagram here. So remember, the hashtags are the walls. So we have walls all around. Then we have the hallway, which is just a row of periods, a row of empty spaces. And then we see 4 columns coming down from there. We see BA is the first room, CD, BC, and DA. And those letters are representing the amphipods. So the A represents an amber amphipod, B is a bronze amphipod, C is a copper amphipod, and D is a desert amphipod. And I noticed right away that I see 2 of each. I see 2 Bs, 2 Cs, 2 Ds, and 2 As. That's convenient. Well, let's continue reading. The amphipods would like a method to organize every amphipod into side rooms so that each side room contains one type of amphipod and the types are sorted A through D going left to right like this. And if we look at the diagram here, we see of the 4 rooms, the room on the furthest left is only A's. The next room over, I'll call it room 2, has B's. The third room has C's and the 4th room has D's. So they want us to sort the room like this, with A's in the first room, B's in the second, C's in the third, and D's in the 4th room. They have to be in this specific order. That's our goal, I think. Let's continue. Amphipods can move up, down, left, or right. Well, yeah, that makes sense. Their room is so small, they can't go diagonal, or they're going to crash into the walls. So long as they are moving into an unoccupied open space. Makes sense. You don't want to crash into other amphipods. Each type of amphipod requires a different amount of energy to move one step. Amber amphipods require 1 energy per step. Bronze B amphipods require 10 energy. Copper C amphipods require 100, and desert ones require 1,000. Wow, desert ones are like the grandpas, I'm guessing, and amber are like little toddlers running around everywhere. The amphipods would like you to find a way to organize the amphipods that requires the least total energy. Okay, so we need to move them around, get them into their rooms with the least total energy. But, however, because they are timid and stubborn, the amphipods have some extra rules. Okay, this sounds really important. Let's read carefully. Amphipods will never stop on the space immediately outside any room. Okay, the space immediately outside any room, they can't stop there. They can move into that space so long as they immediately continue moving. Specifically, this refers to the 4 open spaces in the hallway that are directly above an amphipod starting position. All right, and Alex is highlighting those in the chart down below for you. So those spaces, you cannot have an amphipod stop there. They will never stop on those 4 spaces. That's illegal. Next rule, amphipods will never move from the hallway into a room unless that room is their destination room. And that room contains no amphipods which do not also have that room as their own destination. Okay, so that seems to mean to me that amphipods can't temporarily duck into a room that's not theirs.
Even if it is theirs, they can't duck in if
If
it's not already filled with only their
yeah.
families.
So if we take the first room, for example, room number 1 should only have A amphipods at the end. So if there's, for example, a C amphipod in there, then an A amphipod cannot enter. And any other amphipod cannot enter that room at all, because only A's can go into that room. But we notice in our starting position is a B amphipod in there. So he's going to have to get out. And that's okay. He can get out, but nobody else can come in except an A. All right, let's keep reading. If an amphipod's starting room is not its destination room, it can stay in that room until it leaves the room. For example, an amber amphipod will not move from the hallway into the right 3 rooms, and will only move into the leftmost room if that room is empty, or if it only contains other amber amphipods. Okay, so again, let's look at that B that's in room number 1 right now. That B can stay there as long as he wants, really. But once he leaves the room, he cannot go back in. And the third rule here, let's read this one. Once an amphipod stops moving in the hallway, it will stay in that spot until it can move into a room. That is, once any amphipod starts moving, any other amphipods currently in the hallway are locked in place and will not move again until they can move fully into a room. Okay, so essentially, each amphipod can only move at most 2 times. They can move 1 time to go into the hallway. They can move as far into the hallway as they want, but they move their first move will be into the hallway, and then their second move has to be into their room. They can't move extra times. They can't just keep going back and forth in the hallway. They can only move 2 times, into the hallway and into their room. Does that make sense? Well, in the above example, the amphipods can be organized using a minimum of 12,521 energy. One way to do this is shown below. And we have our starting configuration with BA in room number 1, CD in room 2, BC in room 3, and DA in room 4. So step 1, 1 bronze amphipod moves into the hallway, taking 4 steps and using 40 energy. You see that bronze one right there. He moved up 1 and left 3. So he moved 4 total steps. And notice that he is in front of the wall between 2 rooms, but he's not directly in front of a room because that would be illegal. Next step, the only copper amphipod not in its side room moves there. Okay, so we see now that the C that was in room 2, he moved over to room 3. That took 4 steps and used 400 energy because he's an old man. Next, a desert amphipod moves out of the way, taking 3 steps and using 3,000 energy. And then the bronze amphipod takes its place, taking 3 steps and using 30 energy. All right, so the D that was at the bottom of room number 2, he moved out into the hallway. And the B amphipod that was currently in front of the wall in the hallway moved into his own room. All right, next, the leftmost bronze amphipod moves to its room using 40 energy. Okay, so now the final B went from room number 1 to his place in room number 2. So now look, if we look carefully, we see that room number 2 is finished. It only has B amphipods. And room number 3 is finished. It only has C amphipods. So now we just have to worry about A and D, room number 1 and room number 4. So next step, both amphipods in the rightmost room move into the hallway using 2003 energy in total. Okay, so the D moved out to and he moved 1 up and 1 left. So he moved 2 times, so 2000 energy. And the A that was at the bottom of room 4 moved up 2 and right 1. So 3 energy for him. Now it looks like the Ds can finally enter their room. So both desert amphipods move into the rightmost room using 7,000 energy. Okay, they both go in there. Now they're finished. Now we just got to get that A into his room. Finally, the last amber amphipod moves into its room using 8 energy. What is the least energy required to organize the amphipods? All right, so I noticed right away that D's are going to be the really important ones. We don't want to move D's out of the way unless we really have to, because they cost so much more energy than everything else. Other than that, this one,
This one is easy to understand, but
I think so. You got to be careful about the rules, though. You be careful that you can't move a thing more than twice. For example, if you move an A into the hallway, you can't move him again in the hallway. He's got to go from the hallway straight into his room.
so you would need to know at first where everything is to be sure.
Yeah, once you find a spot, you're stuck with it. That spot either being in the hallway or the spot being in the room.
Yeah, so it's just organizing things.
Okay.
All right, good luck.
Good luck.
No more questions on this one?
No.
Just remember the rules carefully. There's only a few spots where each amphipod can actually sit in the hallway. Yeah, so there's only 7 spots in the hallway where amphipods can stop.
And some block other rooms.
Yeah.
To kind of be choosy about which.
Yeah, and you
which
can't
spot
go.
to take.
You can't go through another amphipod. If an amphipod's sitting in the hallway, you can't just teleport past him. All right.
Cool.
That was a nice short one to read. Not like, what was it, day 16?
So let's go on to question 10. We'll review real quick and then get into answers.
This one.
So day 10 was syntax scoring, a bunch of symbols. I think we ended up in a side discussion about crazy languages. Well, here's almost a crazy language. Each of them means something. Your job is to find which one of these are valid and which one of these are invalid based on enclosing structures, right? So once you open a structure, you can nest, but you have to close structures in the same order that you open the structures, right? So you have to find which ones are invalid and which ones are valid. And then let's see, the actual question for part 1 is.
We have a scoring system.
Yeah.
So we have to find the first illegal character and then look up that illegal character's score. So we see the round brackets have 3 points, the square brackets are 57, curly brackets are 1,197, and the angle brackets are the expensive ones. They're 25,137 points.
What do we call these? We wanted the question, the word for them.
I like my name. I like round brackets, square brackets, curly brackets, and angle brackets. I forget what we called them the other time.
Red B.
Yeah, I read it. I think we called it chunk, right? Round chunk.
That was it.
Curly chunks.
Chunks,
Yeah.
chunks within chunks.
Yeah, round chunk, angle chunk and stuff.
Very chunky. All right.
Anyway, so after we get all of the illegal characters, we have to
Add up the points.
sum up the points.
Yeah.
So for example, if I have, I don't know, if I have 1 square bracket and 1 round bracket, I'm going to sum those up. I'll get 60 points.
Okay. And you got multiple lines, so you got lots to add up. Because each line is going to have 1 illegal character, since you're only going to stop at the first illegal character for every line.
Yeah.
And then you add up
Well,
all
I
the
think
totals and lines for those who are illegal.
well, actually, not all of the lines will even be relevant because some of the lines are corrupted. Some of the lines have illegal characters, some don't.
No, the ones you're looking for are the corrupted.
Yeah. So we have to find which lines have which lines are corrupted, and then get the illegal character. If it doesn't have any illegal characters, then you're not going to count anything for that line.
Right, that's our points.
All right.
So who wants to show first?
I guess I usually go. I can show.
Right.
Let me make sure I'm going to share the right thing.
Always good.
All right. I'm ready. Here we go. Can you see my code? All right. So first, like always, I import my file. Let me see what my code, what my input actually looked like. I had 90 lines of just this junk. Okay. So I'm going to talk about it with the sample first, because the sample was a lot smaller and easier to read through. So first I imported it, I split it based on the new lines, and that's all I had to do. So my final thing is going to just be an array of strings. I cut off a lot here. I only showed the first 3 because I didn't want it to be too long in my code. So this is what it'll look like though. It'll be an array of strings and we can see all the brackets there. And now this is the meat of my code here. The main thing I did is I pretty much did a for loop. So I just did it in a for each function where I'm going to loop through every element in my array. I'm going to loop through each row and I'm going to have a while loop in there. So the reason I have this is I want to go through each row, and in each row, I want to continually remove pairs. So I'm going to find any pairs. So if there's angle brackets right, or the round brackets right next to each other, or square brackets right next to each other, or curly brackets or angle brackets, if they are right next to each other, then I can remove them. I can ignore them. They are no longer important to me. Because if they are together like this, that will never be an illegal pair, right? It's already closed. It's finished. It's good. I can get rid of it. And that'll allow me to get to the outer brackets, the ones encapsulating those ones. So what I do is I just go through and I remove any pairs. Every time I find a pair of any of those, I'm going to remove it. So this match function is just going to return, I think it returns an iterable, maybe similar to an array of all of the elements that match. So I'm going to check the length of that. If it's greater than 0, then I'm going to replace those elements with an empty string. So essentially, I'm just removing all of those elements from my string. So after I do that on all of my rows, I end up with my input looking like this. I have now removed all of the pairs. So if you see in this one, we only have opening brackets. And here too, we only have opening brackets. In the next one, I see mostly opening brackets, but I do see some closing brackets in the middle here. And so now all I need to do is track my illegal brackets, my illegal chunks. So I created an object here to store how many of each illegal chunk I find. So I'm going to keep a counter for each character. Now I'm going to again loop through all of my data. I'm going to loop through each row and loop through each element in that row. And just to make it a little bit easier to work with, I'm going to initialize a variable here. A is just the current element that I'm inspecting. And I'm going to check if A is a closing round bracket or a closing square bracket or a closing curly bracket or a closing angle bracket, then I know that that must be an illegal character because it cannot be next to its pair, its partner, because all of the pairs have been currently removed. So if it is an illegal character, I'm going to increment the counter in my illegal object for that character. All right. And now all I need to do is sum up the count for each character. So I get my illegal round brackets. I'm going to multiply that by 3 because that's its score. Add that to the other ones, multiplied by their respective scores. And I'm going to console log my answer.
So you're using the power of regex on this one?
Yeah. Yeah, so I just sequentially removed all of the brackets. So let me go through and I'll show you essentially what it would look like, what the code is essentially doing. So is it too big?
No.
So if I take my first one here, I take my first row, my code's going to go through and it's going to look through. Okay. Oh, this one matches my regex. So I'm going to get rid of it. Oh, this one matches my regex. Get rid of it. This one matches. Let's get rid of it. This one matches. Get rid of it. This one matches. Get rid of it. And then it's going to loop again. So it's going to search again. I'm going to, oh, now this one matches. Get rid of it. And this one matches. Get rid of it. And it's going to loop again. This one matches, get rid of it. And now it's going to check and it's no longer going to match anything. So it's going to stop. So now it's going to go to the next line. It's going to look through, oh, this one matches, get rid of it. This matches, get rid of it. It's going to continue. This matches, get rid of it. And then it'll loop again. See, okay, now we have more matches. So get rid of that one. Then we can get rid of this one and loop again. Now we have new matches. We have this one, and, oh, I missed one over here too. All right, so now that one's finished. And I'm not going to bother doing it on the third one. I think you get the idea. So because I actually changed my original array, so my new input now looks like this. So now I can know that the very first time I come to a closing bracket, it must be illegal. So in the third row, this one is illegal. Rows 1 and 2 do not have anything illegal. They are not corrupt lines. They are okay.
They are incomplete.
Yeah, they are incomplete lines. Row 3 is corrupt because it has this illegal closing bracket. And notice how if I change that bracket to a square bracket, then it would be okay because then I could remove that one. Sorry. I could remove those. That's a pair. And I could remove those, and then now it would be a pair, and now it would be incomplete. but it had a corrupt element, so it's not.
So there's a distinction here in the problem description between an incomplete and a corrupted.
Yeah,
And the corrupted are the ones that we're interested in. The corrupted ones are the ones that close illegally. And so we're looking for those. Okay, and so that's why you also eliminated pairs.
yes. Because even, well, we'll get to part 2 later. But for this part, there was no reason to even continue looking at anything with the pair. I
Yeah.
could just remove it and look at the leftovers.
You could probably save one regex by just doing the replace and getting a link of it and then comparing it to the last time you ran the replace. Instead of running a replace and a match.
Interesting, yeah.
Yeah, if you do something like a modulo 2 to check the length, you could get rid of all the incomplete right away, no?
Oh, no, because you can have 2 open ones, or you can have 3 open ones.
No, but if the length is not an even number, we already know that's incomplete.
If it's not even, but even if it is even, then you can have a legal open, but an illegal close, and that would be true. You can have 2 legal opens and then have an illegal close, and that would also be a corrupted line.
Corrupted, but I think the question is like, if it's incomplete, we don't need to care about it.
Yeah,
So we could skip some step. Like we know if it's let's say, if it's not even, so it's incomplete, so we shouldn't care for the question number 1, no?
Yeah. For question number 1, if it's incomplete, you ignore it for now.
Yeah. So we could.
I'm not sure that the string length alone is able to
no, you
determine
can't,
whether it's incomplete though.
because you could have 5 pairs or 6 pairs or 7 pairs, but if it's incomplete, you'll only be looking at half of the number. So your length of your incomplete line won't be even or odd or necessarily.
And there's nothing to stop you from having, for example, 2 open round ones and a illegal square bracket close, or 3 open round ones and a legal square bracket close. Even in the incompletes can have 2 round brackets or 3 round brackets, and both of those, regardless of their even and odd, are considered incomplete. All right, try it. So you know for sure, right?
Mhm.
Anyways, who wants to go
Hey.
next?
Yeah, I will go.
Questions on this one? I was thinking about what you said, Alex. I don't know if I could replace this one because I need to save the result of my replace one.
You say the length.
But if I save the length, then I can't also save this one here. So I want to rewrite my current element with what it's replacing.
So if you
So
say,
I want to modify my original element, but can I modify it and also save the length?
well, for example, in your while loop, you need one more variable to have the length of the last match. So you have one more variable to say the length of the last match. In your while loop, you just make sure the 2 lengths are different.
Okay.
And then if the 2 lengths are different, then you're going to replace again. And then after you run the replace, you assign the new length to the length of this I at the end. And you run the while loop again. And then you compare the 2 lengths again.
Okay.
Yeah.
Yeah. Yeah.
Whatever.
Get rid of 1 rejects. That is very ugly. I should have just put this into its own variable.
It's a language in and of itself, right?
Yeah.
Looks like you have match groups in there as well.
Yeah, so I have a lot of escape characters because they're using brackets. So a lot of this is just escape characters.
Oh, okay. Okay. So you're not using.
So I'm using ors.
Oh, but you're using matching groups.
So I have this one, I'll talk about the first one is essentially, a matching group of an open bracket and a closed bracket. So it's a matching group there. So if I have an open bracket and a closed bracket together, or if I have an open square bracket and a closed square bracket together. or if I have an open curly bracket and a closing curly bracket together. Or, and this one's nice because I didn't need the escape characters, if I have just open and close angle brackets.
Did you need the capture groups thing?
Maybe not. I'm not great with rejects.
My understanding was that the capture groups are if you want to reuse them in like replacements. You're wrong, but that's what I remember. And
Do this one to
then,
the next one, let's see.
and then for the whatchamacallit, the symbols that you have, like for the one that's next to it.
Yeah, I think that's the same answer I got.
Yeah, the symbols that you have for the one that's next to it, like slash slash. Why is the first slash, for example, do you remember why you have those in parentheses? And the second ones you have in square brackets, and the third ones you have in curly braces?
This one?
Yeah.
Okay. Those are escape characters. So
Okay.
I
I'm
have
reading
it-
it wrong. I'm completely reading it wrong.
Yeah, because these also have meaning in a rejects, I had to escape those.
Yeah, no, I
So
was,
that's
looking
all
at-
the slashes
I was
are.
focusing on the slashes instead of focusing on the actual.
Yeah,
No, okay. That makes
so
sense.
that's it. But angle brackets don't have any meaning in a rejects, so I didn't have to escape those. All of the other brackets do have meaning,
Yeah. that
so
makes
they need
sense.
to be escaped with the forward slash.
Right.
But yeah, I didn't need the capture groups, it turns out. So makes it a little easier to read.
Yeah,
It's a little ugly with all the escape characters.
No. it's hard. Regex is not read friendly.
Yeah. All right, so yeah, this one didn't take me too long. I was lucky that my initial thoughts about it ended up being correct.
Yeah.
My fault. I didn't have to redo anything. So,
Okay.
what's next?
Alexi, did you do or no?
No, I didn't do it.
Okay, Python. If that's fine. Right. Regarding my approach first, before the code. So I'm taking all of my inputs as an array of strings as displayed here. And then I'm looping through each one of them. And one by one, I'm storing them into a stack or array. So I will take my first element and store it in my stack. Take the next one, third one. As long as they do not meet the pair yet, I will keep storing them in my new stack. So they move here, and this also move here. And I'm also checking that if the last element in my stack pairs with the first element that I am currently on in my old array. So for example, here, my element in the array matches or makes a pair with the last element in my stack. So I pop it. And next element in my array also makes a pair with the last element in my stack. So I pop this one too, my stack, and I go on. I put this one into my stack. And next one makes a pair with the last one in my stack. So I pop them. And this one makes a pair with the last one in my stack. I pop this one, and so on. So I basically, at the end, I have the pairs, or I have the leftover brackets that do not have a pair in my stack. I will store it in my array or array of stacks. So that's my approach. And as long as I get an ending pair that doesn't match with the last one in my stack, I will regard that line or regard that line as an corrupted line and take a record of my corrupted bracket. So if it's a closing bracket, but it doesn't match with the last one in my stack, that's a corrupted line, basically. Okay, that's my approach. And here's the code. So first I have my input as an array of strings, and I have an object of my correct pairs, and I have my ending pairs or it's a wrong name, but basically ending pairs. And I have my stack, and I have an array for my corrupted lines. So I'll keep a record of my corrupted lines. So for my lines in my input, I have an empty array, and I'm starting to loop through my line character by character. So if it's the first element, which is at 0 index, we don't have anything in my stack yet, so I'll just append it to my array. If the last element from my stack, and I will get its pair, I'll get the last element in my stack, and from my object here, I'll get its pair. So if it matches with my current character, which I'm looping through, I will pop that from my stack. And if the last element in my stack doesn't match with the current one, doesn't make a pair with my current element, but my current element is an ending pair or ending bracket, that's a corrupted line. So I will append this entire line into my, I will append this character into my corrupted lines array, only this character. Otherwise, I just keep appending to my stack. And I will, at the end, I will append my temp, which is this temporary array, into my stack array. So stack is an array of strings. This means the leftover pairs of a line. So what I need here is this corrupted lines array. So if I print it after loop, it will contain the corrupted brackets or brackets which make my line corrupted, because that's what all I need to complete to get their sum. And I have my scores for each bracket. And yeah, I will loop through my corrupted lines here, these brackets, and get their sum and return it. Yeah, this is the approach.
I like yours a lot. It seems essentially you did the same thing as mine, like finding each pairs and getting rid of the pairs, but you did it a lot more efficient. Like where I have to loop through, get rid of pairs, check again, get rid of more pairs, check again, get rid of more pairs. And then finally checking like all of my lines, character by character, to find the illegal character. You pretty much did all that in one loop.
Mm-hmm. Yeah.
You just start at the beginning, you go through, oh, there's a pair, pop it off, oh, there's a pair, pop it off, oh, there's an illegal character, catch it. That seems really efficient, I like it. Perfect usage of a stack.
Yeah, this approach, I was familiar with it, this bracket and pair stuff when we covered stacks at university, so that helped quite a bit. Yeah. The approach of finding or counting pairs, yeah. And also it was useful, yeah, we'll get to this later, but this approach also turned out to be useful for part 1 too for me.
You mean for part 2?
Yeah, part 2, yeah. I will get to it later, but that's it. Any questions?
Nope.
I've never used a stack before, but this seems like a perfect question for it. You do. Nice.
Okay.
All right. Now we'll go to mine. If I remember what screen I have. So my approach is the same as Ferg's. I use a stack as well. I think some of this is somewhat familiar. This is the same as Ferg's code. Things are matching brackets. The only difference is I have open brackets instead of closed brackets. I also have a vector of corrupted that I'm going to fill in as I go through each line. And then for every line and for every character in a line, I'm going to see if the open can, if it's an open bracket. And if it's an open bracket, then I just push it. If it's not one of the open brackets, which is kind of opposite, I think what that group did, but same idea. If it's not an open bracket, then I'm interested, right? Because it's one of the closing brackets. And then since it's one of the closing brackets, I pop it, compare it against what its pair should have been. And if it doesn't match the pair, then it's considered corrupted. And that's it. And then for the points, have a structure or basically a switch statement for all the points. So as I go through all the corrupted symbols, I have a switch statement, and the switch statement essentially allows me to in this loop sum up all my all the closing illegal brackets it has found. But I think pretty much went through
The process.
the process. I'm not going to rehash it, but yeah, that's pretty much what it is.
Same thing, different method.
This is a really common problem, no? Used to explain stacks and stuff. These brackets.
Yeah, well, the brackets itself not, but the idea that you're trying to find something that pairs up with something else, and there's a very definitive order to it, right? But it can also happen in other parts of data structures. But as long as you have this idea of nesting, like things nest inside each other, whether it's objects, whether it's brackets, whether whatever it is. If you need to unravel that nest in the same order that you've made it in, then a stack is perfect.
Going back to day 18 now. with this new knowledge, I'm going to be able to solve it. See, I didn't do a CS degree, so I never learned about stacks at all until essentially just a few days ago. I started touching about them. So this is something I need to learn. Seems really useful.
I think the three basic data structures you learn in 101 is like stacks, queues, and linked lists. And then from those three, you can pretty much build out on most of the complex data structures that are built. Okay, I'll go to part 2 since I'm already here.
Yeah, well, let's read it first or summarize it.
Sure. Part 2 is we're going to take our incompletes
And
try to complete them.
tally the scores for the completion strings of the incomplete ones.
Right.
So part 2 is the opposite of part 1. Part 1, we ignored the incomplete rows. Part 2, we're ignoring the corrupted rows. We're just completely throwing away the corrupted rows. We're only looking at the incomplete rows. Incomplete rows need to add extra brackets at the end in order to complete. So we're just going to be adding those brackets in order. So that's one of the key things here is we need to find out the exact order of the brackets. So you can't just count the number of square brackets, count the number of round brackets, and then use that. No. It needs to be in order because the scoring system that we have to use now, it involves starting with a score of 0. And for each character, you're going to multiply your score by 5 and then add the score for the next character. So round brackets are 1 point, square 2 points, curly brackets are 3 points, and angle brackets are 4 points. So every time for every character, we're going to multiply our score by 5 and add the points. And then for the next character, we'll multiply our total score by 5 and add the new points. So you really need to get the correct order of the brackets to finish the sequence. And then there's more though. You're not taking a sum this time of total scores. This time you have to find the score for each incomplete row. And then we're going to take if we sort that from high to low or low to high, we're going to capture the middle score. And that's going to be your final answer, is the middle score for the incomplete rows.
Unfortunately, there's always an odd number of results, so you will always have a middle score.
It's nice how it corrupted so conveniently for us.
All right. Okay, so with the queue, or sorry, with the stack, it makes it somewhat straightforward to do since you already have an idea of what is left open and what you need to close. So most of my code ends up looking pretty much the same. All right, so I should have had more comments in this one. I'm trying to read through it and making sure just by glancing whether everything's the same. But I think pretty much everything is the same, except we're not catching corrupted anymore.
I think the way that you're finding the corrupted ones is all the exact same.
Yeah. And so, we have a line in here for not corrupted. I'm going to take my brackets and reverse them. Why?
You want the mirrored image for the closing ones. Because the brackets you have left then are going to be opening brackets, right?
Yeah, but reverses a order of a data structure. It doesn't actually change, doesn't flip the character itself. That'd be nice. I'd be done.
Yeah.
But let me see what I stuck in brackets. What did I put in here to begin with? Oh, brackets is my stack. For some reason I decided to reverse the stack, maybe because I'm gonna pop or pull off the beginning. I don't know, but we'll see. So for to close to brackets, oh yeah, because I'm gonna use an iterator through it. And so because I'm using an iterator, I'm not going to pop off the end of it and I start from the beginning and move from the beginning to the end. So I do want my data structure reversed. And so I reverse my data structure so I can take that stack and start from the beginning like a queue. And then let's see, position XX. As long as X is to close or to close in brackets, what is X? X is a position of the open brackets. Oh, so I'm going to see what position these are in 0, 1, 2, 3, 0, 1, 2, or 3. And then using 0, 1, 2, or 3, I'm going to, well, since we're 1 based instead of 3 based, 1, 2, 3, 4, 5, the position will be 0, 1, 2, 3, but the points is going to be 1, 2, 3, 4, so it's just +1. So I actually made my data structure the same order as my point structure. And then whatever that is, and then make sure I multiply by 5, push that into a structure, sort the structure, get the midpoint, and then print out the midpoint.
All right. Not a whole lot of extra code from part 1.
Nope, not a whole lot. Okay. Any questions? I'm going to guess that Farouk's is pretty much the same. So why don't you go next, Farouk? Oh, you're on mute, by the way.
Okay, I'm going next. So my up or first half is pretty much the same. I didn't change anything because I'm keeping track of my incomplete lines as I go through every character in each line. And if that line is incomplete this time, in my first attempt, if the character or line is incomplete and I was appending my bracket, which makes the entire line corrupted into this corrupted lines array. But this time I'm just skipping it. If it's a corrupted line or yeah, if it's a corrupted line, I will just do not take that into any record. I will just I will not append it to my resulting stack of arrays. So I'll just break my loop and go on. So at the end, I have my stack, or so if I print it, I have my array of arrays. Yeah, so if you see, it's an array of arrays, and every time this is the first half of my incomplete line, right? So these are the ones which I need another pair for. These are the ones which need a closing pair. So I'll just reversing my Oh, it's not doing anything here.
You're essentially doing the same as I did. Because you want to use a for loop which goes from left to right, whereas your stack is meant to be popped from right to left. You could have also used a while loop and we could have just kept on using pop until the array is 0. It's one way to keep it without doing the reverse. Or use an iterator with next.
First, reversing my stack array, right?
Yeah,
But I'm
reversing it so you can use it in the for loop.
but I'm getting the same.
No. It's reversed.
Ah, okay. I think I have my last. I mean, okay.
Well, you're reversing each individual array inside the array, not the.
Further elements are reversed now.
That's why they have the sub X.
Okay, so I'm starting from the middle. So after that, I'm going through each one and getting their multiplication and sum gets the result. And after that, sorting my result, and I have another function, find middle, which will return the middle element in my list of the sums. And I'm returning that middle element from my list.
Cool. Can I see your find middle really quick? What's that second one?
Which one?
Oh, the second one's if the number is even, you're going to return a tuple. Interesting.
Did you miss the line in the problem where it said that the question or the result will always be an odd number?
Oh, really?
Yeah, so you didn't even need a condition in your find middle function.
I think I missed that one then.
Okay. So you have a solution that essentially either returns a middle input or returns a tuple if it's an even number of the two that are in the middle.
Yeah, in the problem, it says there will always be an odd number of scores to consider. So they made it a little bit easier, whereas you tried to handle that. Cool.
And
Yeah, you don't even need a condition.
right. I'm wondering if I took this find middle stuff. If I'm wondering if it was the work of the copilot. Because this part, confusing for me too, tuple part.
Yeah, returning a number of tuple. It's
two numbers basically in a group, right?
Trying the same thing.
It's disabled now, so no worries.
Anyways, it works. Good job.
Yeah, so basically what I found useful for the part 2 was I already had an array of my incomplete characters. So from there, it was easy to get the result.
Yeah.
I think this was one where part 1 and part 2 went together pretty easily. I guess I'll share mine.
Yep.
Okay, so again, for my part 2, I was able to reuse a lot of my old code. So I kept my initial thing where I reduced all of my initial inputs into the same input with all of the pairs removed. So I removed all the pairs for every row, whether it's corrupt or incomplete. And then I took my other loop that I used to use for counting the illegal characters. And instead, I just used that to find an illegal character and remove that row from my input. So now my input will only have the small ones. So with the pairs removed and all of the illegal ones removed. So it would be like this, but only with incomplete rows. So now all I got to do is just go through my incomplete rows. And since I removed all of my pairs, I know that to complete that incomplete row, I pretty much just need to add in the mirror image of what that row currently is. to complete all of the brackets. So in JavaScript, I can do that by looping backwards through every element. So I just started with my J as the last element in my list and decremented my J every time I loop. So that'll essentially start with the last element and loop to the first element, which is a nice way to do it here. Then I can just add in all of my scores. So of course you have to do this conditionally because each thing has a different score. So initially I started my score at 0 for each row. I'm going to multiply by 5 initially, and then I'm going to add 1, 2, 3, or 4 based on what character I have. And now I'm going to add that to a scores array that I created up above here. So this is going to store the score for every incomplete row. Now all I have to do is sort through that. So I sort my scores array and capture the middle element. And console log that, that's my answer. And then I was having a little fun with JavaScript. For some reason, I got into my mind that I wanted to use like images and weird, funny emojis as variable names. And I found that you cannot do that. But I did find a few like ASCII characters that are kind of cool that you can use as variable names in JavaScript. So this one, I can use that for an elephant or a pig, and I guess that's a pufferfish. Does that look like a pufferfish to you?
Yeah, that's about right.
And a duck and a monkey and a hare. I call it a hare instead of a rabbit because it looks like it has longer ears. I don't know, a goat and a scarab. And interestingly enough, all of these are from like the Egyptian hieroglyphics in ASCII. Those are the only cool pictures that I can find. Anyways, that's completely unrelated to this problem.
Where did you get those? How do you type?
I don't know how to type it. I copied them from Wikipedia, Wikipedia's ASCII entry.
So if you want to use it, you have to copy and paste that, right? That variable name.
I'm sure there's a keyboard command, but it's probably not easy to remember.
I think if you have a number pad, you can use Alt and then a 3-number digit,
Yeah.
a
A
3-digit
4-number
number,
probably, yeah.
a 3-4-digit number.
I don't know how to do it on my Mac. On Windows, it would be like Alt U 2365 or some random combination that you would have to memorize for every single one. So they're unusable, but I thought it would be fun. I would never use it in real code, but for advent of code, when you only have to use a certain variable maybe a few times, it could be fun.
There are people who try to obfuscate some malicious code by using blank spaces or non-character spaces or very thin spaces. So you're actually adding spaces when you're not actually adding spaces to see whether or not it'll break your code. So for example, if the database normally doesn't take a space, you can put in a non-character space and see if that will either take it or break it.
Interesting.
There's a lot of ways you can screw around with things outside the normal character set.
Day 24 should be up now.
Oh, yeah. All right, so any questions before we move on from question 10 or question 10 part 2? Looks good.
Next one, we have Dumbo octopuses.
Again?
Solving like 11.
Oh, okay, next day. Yeah, 24 is up.
Okay. Oh, it doesn't look too long. Good.
Okay.
Release.
Line unit.
Oh,
Farouk, Alexi, one of you guys want to take this one?
okay, I can take it.
Okay.
Right. Arithmetic logic unit. We have our arithmetic now. A magic smoke starts leaking from the submarine's arithmetic.
That's a link.
It's a link. Magic smoke.
Smoke. Colorful smoke? What's
Magic smoke, also called factory smoke, blue smoke, or the genie. Produced by severe electrical overstress of electronic circuit components.
Okay.
It's what runs things. It's it's what makes electronic things work. And then when the magic smoke escapes, things stop working.
Mhm.
The
Yes.
blood of modern electronics.
Okay, yeah, that's kind of a funny joke, I guess.
Has led to phrases and variants of, you let the smoke out, or there's too many angry pixies running around the circuit. The magic smoke is escaping. I think you set your power supply too high. There's magic smoke coming from that resistor. When a device is powered on for the first time, it's often called the smoke test.
Okay.
Right. Anyway,
Smoke use.
moving on.
Magic smoke.
Magic
All
smoke.
right, sorry for that aside, Farouk.
Magic smoke starts leaking from the submarine's arithmetic logic unit, ALU. Okay, without the ability to perform basic arithmetic and logic functions, the submarine cannot produce cool patterns with its Christmas lights. Wow, what a problem!
This seems very serious.
What a serious problem. It also cannot navigate, all right, or run the oxygen system. Okay.
Christmas lights.
Oh.
It's the Christmas lights.
So yeah, I like that they started with the Christmas lights and then they got to the life-threatening things.
And navigate.
ALU is an important part of the submarine's navigation system. Okay, do not worry. So you probably have enough oxygen left to give you enough time to build a new ALU. Wow, we have to build a new one.
Oh.
They emphasize probably.
The ALU is a four-dimensional processing unit. It has integer variables W, X, Y, and Z.
Oh, four-dimensional already hurts my brain.
Yeah, it's four-dimensional. These variables all start with the value 0. The ALU also supports 6 instructions. So it has variables and supports 6 instructions. Input A, INPA. This means read an input value and write it to variable A. So, okay. So somebody has to give the command INPA and then provide a value after it, probably, I suppose. Add a B, add the value of A to the value of B, then store the result in variable A. Okay. Second instruction, third one is MULAB, means multiply the value of A by the value of B and then store the result in a variable A. Okay, DIVAB, divide the value of A by the value of B, truncate the result to an integer, and then store the result in a variable A. Here, truncate means to round the value towards 0. So we have to down. Yeah, we have to take it down.
Or up if it's a negative value.
Yeah. MODAB divides the value of A by the value of B, then stores the remainder in variable A. This is also called the modulo operation. Okay, we have to get the remainder of the result of dividing A by B and store it in A. EQLAB, if the value of A and B are equal, then stores the value 1 in variable A. Otherwise, stores value 0 in variable A. This has instructions. But I'm wondering, we do not have an instruction to store a value in B. We can only store a value in A.
I think you can store it in B by just switching around the variables. I think these are just examples of how the instructions are, but I think you can do it in any order.
The one that's going to be problematic is division, because division's not commutative.
Okay, so you are saying we can use INP, like the first instruction, and pass a B instead of A?
What's that?
So Scott said you can switch the parameters. Do you mean?
Well, for example, for add, I think I can do add BA. And then it would add the values together and store the result in variable B. So that's what I'm assuming, is that we could swap the variables or even have new variables. Our input might actually have like A, B, C, D, E, F, G, I don't know.
Okay, yeah, let's read it.
It's just showing the
It's
order.
just a variable
the
on
order
the
of how
left.
it
It gets
works.
stored in the variable on the left.
Yeah.
The letters themselves are kind of just there for, make it easier for us to read, but it's add, first variable, second variable, adds it
Yeah.
together and stores it in the first variable.
Yes.
Okay, so in all of these instructions, A and B are placeholders.
There you go. Explains it right there.
We were ahead of ourselves.
A will always be the variable where the result of the operation is stored, one of W, X, Y, and Z, while B can be either a variable or a number. Numbers can be positive or negative, but will always be integers, okay? So we can pass one variable and one number to make these operations. The ALU has no jump instructions. In an ALU program, every instruction is run exactly once in order from top to bottom. The program halts after the last instruction has finished executing. Okay, so we cannot jump from the start to the end. We have to follow the order of the instructions. Program authors should be especially cautious. Attempting to execute div with b equals 0 or attempting to execute mod with a smaller than 0 or b smaller or equal to 0 will cause the program to crash and might even damage the ALU. These operations are never intended in any serious ALU program. Okay, so it basically means we should assume that the zeros are not passed to our program, right? And we do not have to handle the edge cases. For example,
I think we gotta keep reading. It could be like where we have to find the failures or something.
okay, so yeah.
Come back to it. Let's keep that in
For
mind.
example,
Come back to it later.
example, here's an ALU program which takes an input number, negates it, and stores it in X, INPX, MULX, and -1. Means we take the input number and store it in X and multiply it by -1 and store it in X. Here's an ALU program which takes two input numbers, then sets Z to 1 if the second input number is 3 times larger than the first input number, or sets Z to 0 otherwise. So in INPZ, INPX, MULZ3, we are multiplying Z by 3, and we are checking with EQL, ZX, we are checking if they are equal. And if they're equal, we are storing the 1 in Z. Otherwise, we are storing 0 in Z, I think. Set 0 to Here's an ALU program which takes a non-negative integer as input. Okay, converts it into binary and stores the lowest 1's bit in Z, the second lowest 2's bit in Y, the third lowest 4's bit in X, and the fourth lowest 8's bit in W. Okay, let me read this one more time. It's an ALU program which takes a non-negative integer as input. Okay, and we can convert it into binary and store the lowest 1's bit in Z, second lowest 2's bit in Y, the third lowest 4's bit in Y, and fourth lowest 8's bit. Do you have an operation to convert to binary?
That's what this is doing. So let's go through this and see how it's actually doing it.
The first command, INPW, we are storing a value in W. Add ZW, we are adding the value of W to Z and storing it in Z. And MOD Z2 means we are storing the remainder of the division of dividing Z by 2 in Z. And div W2 means we are dividing W by 2 and storing the result in W. Add Y and W. We are adding W to Y and storing the result in Y. MOD Y2. We are storing the remainder of dividing Y by 2 in Y. div W2 means we are storing the result of dividing W by 2 in W. Add X and W. We are storing the sum of X and W in X. MODX2, we are storing the remainder of division of x by 2 in x. DIVW2, we are storing the result of dividing w by 2 in w. MODW2. Because this one I didn't understand actually. So how are we converting the non-negative integer to binary here?
Dividing by, well, anyway, to convert a number into binary, you have to convert it into twos. Like how many twos are in a number, right? So if you take, for example, the number 10, you got to first find out how many are in the first digit, the second, the twos, the third, the fourth, and the fourth, the eights. And so one way to do that is to keep dividing it by 2. And by constantly dividing it to 2, if you know how many, if you get an idea of how many digits there are, then you get an idea of how many times or how large this number will be in binary in terms of ones and zeros. So, the easiest one is, 2 divided by 2, and then you take that number and let's see, so 2 divided by 2 is 2, right?
Yeah.
And then you do a modulus, and then which is just getting the remainder, which will give you, of in that particular twos place, what number do you get? And then you divide it by 2, which shifts everything to the right. So let's start with a number that's actually greater than.
Let's do it with 2 then. Like 2 is the easiest one. So 2, if we do 2 modulo 2, we get 0.
0.
So the first bit is going to be 0.
Right.
And then we divide by 2. So 2 divided by 2, we get 1.
Right.
And then we're going to take modulo of that. So 1 modulo 2 is going to give remainder 1.
Right.
So then our next bit is 1. So then we have in binary 1, 0.
Yeah.
And that's 2.
So every time you do a divide by 2, you can think of it as going down through
To the next bit.
to different places along the twos, and then the mod will give you whether it's a 1 or a 0.
Yeah. This might not even be important to the question, though. I think it's just an example.
No, it's an example of an algorithm written with the instructions that they have.
So maybe we don't need to go too in-depth into converting to binary.
That's clear now. Thank you for the explanation, Alex. So once you have built a replacement ALU, you can install it in the submarine, which will immediately resume what it was doing when ALU failed. Validating the submarine's model number. To do this, the ALU will run the model number automatic detector program, MONAD, our puzzle input. We have to validate submarine's model number after our ALU completes. And to do this, we have another detector program. Submarine model numbers are always 14-digit numbers, consisting only of digits 1 through 9. The digit 0 cannot appear in a model number. Okay. When Monad checks a hypothetical 14-digit model number, it uses 14 separate INP instructions, each expecting a single digit of the model number in order of most to least significance. So to check the model number 1357924689999, you would give 1 to the first INP instruction, 3 to the second INP instruction, 5 to the third INP instruction, and so on. So we'll go from left to right. And we'll pass the digits in our model number to our ALU. This means that when operating Monad, each input instruction should only ever be given an integer value of at least 1 and at most 9. Okay. Then after Monad has finished running all of its instructions, it will indicate that model number was valid by leaving a 0 in variable z. However, if the model number was invalid, it will leave some other non-zero value in z. Okay. Monad imposes additional mysterious restrictions on model numbers. And legend says that last copy of the Monad documentation was eaten by a tanuki. You'll need to figure out what Monad does some other way. Okay, Monad imposes additional mysterious restrictions on model numbers. And legend says the last copy of the monad documentation was eaten by a tanuki. Can you check what tanuki is?
It's like a little raccoon thing. Raccoon dog.
Okay.
And
Did any of you ever play the old video game Super Mario 3?
No.
Yeah.
If you remember Super Mario 3, like Mario could get like different suits. Like if you get an item, it gives you like a different suit that you have different abilities. One of the suits
Tail
is
and
Tanuki Mario.
hmm,
From way back in Mario 3, you could be Tanuki Mario. That's
yeah,
how I know the animal.
you got the tail and the hat.
Yeah, he's got the tail and the hat, and he can, I forget what his abilities were, but he was pretty cool.
You got the raccoon ear.
Okay.
call it a raccoon dog.
Yeah.
Japanese raccoon dog.
Yeah.
Okay. Yeah, I think that's clear. It was eaten by a raccoon.
In the submarine?
I think it was before the submarine started, right? Before the submarine went into below the sea, it was eaten probably. Or if we have a tanuki in submarines, then we have a more serious problems than the current one.
Gremlins.
All right. This one seems a little complex.
So
Okay,
I said
Let's, yeah. Then after monad has, okay, monad imposes additional mysterious restrictions on model numbers. And legend says the aspect of monad documentation was eaten by a tanuki. You need to figure out what monad does some other way. So we already have the model number as our puzzle input, no?
yeah, apparently a 14 digit.
No, we don't have a model number. We know the rules.
Oh yeah, we
but
have
it's
the
a
program.
14-digit number.
We have
We
the
have to-
monad program in some weird,
We run the model number.
but
Yeah.
the program itself is supposed to be, because the ALU will run the program, which is model number automatic detector program. So I guess
I think
that
So our input
That
is
list
the
of instructions.
detector program.
yeah, the list of instructions we have makes up the monad where we can feed it model numbers
okay.
potentially.
You'll need to figure out what monad does some other way. To enable as many submarine features as possible, find the largest valid 14-digit model number that contains no 0 digits. What's the largest model number accepted by monad? Okay.
Oh, so we just got to start at the biggest number. Start at a 14-digit number with all nines. What even is that?
Yeah, do a binary search on a 64-bit number and go down from there.
We have our input, but our input is not complete then, right? Because the last copy of the monad documentation was eaten by a tanuki.
I don't know. Let me see. I'll share my input. Oops. So it's just a big list of instructions.
Okay.
And so this instruction is essentially going to, at the end of it, spit out on the Z a 0 or a 1 as to whether it's valid or invalid.
But we have to figure out.
I want to figure out the largest 14-digit number that will result in a 0 on the Z bit,
Yeah.
or the Z coordinate, whatever you want to call it.
So we have to find the largest valid number.
Where the Z variable is 0 at the end.
So I guess our answer is going to be somewhere between 10 trillion and 99.9999 trillion.
Interesting.
Okay.
There's no jumps, which is good. You just have to somehow analyze this to figure out what the heck it's
So
doing.
we only have to check 90 trillion numbers.
So each of our monad is doing different instructions.
Probably, yeah.
And it's getting some of these instructions more than the others. Oh, 'cause
But in order.
it's entering the numbers in W. At least on mine, I don't know if that's true for everybody's, but it looks like mine, all the entries are being entered into a single variable, the W. All my entries are going to W. And then a bunch of stuff happens. Probably nothing to do with W.
Yeah, I don't know what the,
Oh, interesting.
why do I have INTW so many times? Because
You can
What
use
does that
W
even
more than
do?
once. W is just a variable. Remember, every time you do input W, it's going to take a digit starting from the most significant. So the first time, for our example, was 1. The second time was a 3. The third time was whatever, the third one was 5 or 9. 5.
what does INP function do again?
Reads a number and sticks it into the variable.
Okay, but what number is it reading? There's no number following?
No, it's up to you to find
Okay,
the
so that's the
largest
number that
possible
we give
number.
it. That's the number that we give it.
Yeah.
Okay. So then,
It's not using that W variable, right? Anywhere else.
It's got 1.
it is, I see it, I see it a few
It's got
places,
another
yeah, I
one.
see it, add
Okay.
YW. So then when we do the next IMPW, are we restarting with our input number again?
No, you're getting the next digit.
Okay,
That one gets the next digit. Then you do
okay.
a whole bunch of more stuff, and you get the next digit.
okay, so we should have 14 of those, right?
Yep.
Okay.
And you can
Oh,
check.
I get it, I missed that. I read the instructions too quickly. That makes more sense now. So we're just checking each digit sequentially from the left to the right. Right.
We have 11 incrementing, but other numbers are same, like 26 is same. We have, for example, in the first time we have add X and 11. The next one we have, there add X and 11. On the next, after the next input, we have add X and 13.
Okay, so essentially we have different validation rules for each digit.
Next, we have add X15.
Yeah.
Yeah, there.
So we're validating each digit in our 14-digit number.
So we basically have some patterns that we have to find. Okay.
This is there.
Five people solved it. So
I think,
It's
does
been
that
30
mean,
minutes.
does that mean when, after Monad has finished running all of its instructions for that digit?
I don't know. I seem to take it as after it's finished doing all the digits,
That
but
doesn't make sense to
I could be
me.
wrong. Why? But basically, it's the last digit then. The last digit
Yeah.
determines it. And the last digit's already, all the other X, Y, and W have already been or X and Y, I guess, have already been grossly manipulated by all the numbers before it.
Okay. Oh,
okay.
yeah. Okay, cool. Seems like a fun one. I'm gonna try this one before I try others, I think.
Should be cool. Alrighty. Well, good luck. And Merry Christmas.
Yeah, Merry Christmas, guys.
Merry Christmas.
Merry Christmas.
And then we'll see you guys on Monday, where we will cover 25. And answers to 11
Dumbo octopuses, right?
and maybe 12 if the time allows. Let's see.
Cool. We're getting close to the end.
Ah. Interesting, very interesting. Anything else before we wrap it up?
I think we can stop recording.
Stop my sharing, and we'll see you guys later.
Right, bye.
Yes. Woo.